Hi everybody! These are the properties of logarithms notes that we would have done in class today, except Joey was sick, so I had to leave early. Take these notes, write all the examples down. There's some you-try problems in here with the answers. That's going to help you for the bookwork that's listed at the end of the video. It's the same bookwork that was on the whiteboard. Tomorrow we're going to use these notes to solve more difficult types of equations, and then we're almost done with the logarithm stuff you need to know. Here is a list of the smaller properties of logarithms you already know. These two are the ones we just did yesterday and the day before to do method 2 for solving equations. These two are the ones I gave you yesterday. They're the ones that look very simple. They look almost too simple to be a whole theorem, but if the bases are the same of an exponent or a logarithm, they cancel and x is y. These two, just think, what exponent do I give b to get b? It's just 1. It works for ln as well because there's an invisible e right here. We normally don't write that e, but there is an e, and you think, what exponent do I give e to get e? It's 1. And these three right here we've also talked about. So let's move on to 3 more properties of logarithms. Now these properties are used to do what's called expanding and condensing logarithms. And those are things that we're going to be doing tomorrow in class to solve harder equations. So if I want to expand or condense, here are the rules. Now these rules come from the properties of exponents because remember, logarithms and exponents are inverses, so their properties are directly related to one another. We already know the product rule for exponents. If the bases are the same and I multiply and I add the exponents, similarly, if I have a logarithm base b and it's a logarithm of m times n and they're multiplied, what you're going to do is give each of these their own logarithm, and you're going to add. So just like you added here, you're going to add here. Now that's the quotient rule. The quotient rule for exponents we've seen before. If we are dividing, then the exponents get subtracted. So similarly, if I have a log base b of m over n, what I'm going to do is give each of these things their own logarithm because I'm expanding right now. And just like here when I subtracted, I'm going to subtract here. Now the power rule doesn't really come exactly from the properties of exponents. There's not a property of exponents that looks exactly like it, so I'll just give it to you. Log base b of m to the n. What this one says is if there is an exponent on whatever you're doing the logarithm of, and you're expanding, you bring that exponent down front, and what it becomes is n times log base b of m. And if you want to see why that works, let's just pick random numbers here. Log base 3 of 9 squared. So what this says is you could do this. Now 9 squared is 81. Log base 3 of 81 is 4. Or bring this guy out front, 2 times log base 3 of 9. Log base 3 of 9 is 2. 2 times 2 is 4. So it's the same thing. So anytime you're not sure why a theorem works or if a theorem works, you can just plug real numbers in and you'll see that it actually does work. So let's move on up here because I have some examples I want to give you for expanding logarithms. Now what is going on with my pen right now? Come on. There we go. So here's some examples you're going to write down. After this, I'll give you a list. I think I gave you 4 to try. Now, whenever we're going to expand logarithms, that's the first thing I'll show you. What happens is I'll give you a single logarithm. It'll be the logarithm of multiple terms, and you're going to expand it as the sum and difference of multiple logarithms. So sometimes you'll expand it to 5 different logarithms. Sometimes you'll expand it to only 2 different logarithms. One thing to keep in mind when you're expanding is there should be no more radicals. It's not fully expanded unless every radical is gone. And we can do that because we know that any radical can be written as a fractional exponent. So keeping that in mind, let's start with a pretty basic example right here. Let's do log base 7 of x squared times 9. So I have a single logarithm, and it is a logarithm of 2 terms. So however many terms there are, that's how many logarithms you need. So I'm going to give each logarithm each term its own logarithm. Notice that I am multiplying right here. And we already wrote down that whenever we have things multiplied, what we do is we add. So x squared gets its own logarithm, and y gets its own logarithm. And then you don't ever want to keep any exponents. They all should become coefficients out front. Log base 7 of x plus log base 7 of y. There we go. So here's the one that goes with the pink, and here's the one that goes with the green. And again, I'm adding here because I multiplied. So let's try another pretty basic one. ln natural log of x squared over 4. So again, I have two terms here, 1 and 2. And what I'm going to do is give each term its own logarithm. So since there's two terms, there's two logarithms. And because the terms are divided, what I'm going to do is subtract the logarithms, like that. And I don't want this fraction, sorry, this exponent here. This needs to come out front by property number 3 of logarithms. There we go. So let's try one that's a little more interesting here. Log base 9 of, we'll get to the trickier ones together in class on the whiteboards. So you have to decide how many different terms do I have here? Well, I have 1, 2, and 3. So I'm going to need 3 logarithms. So log base 9 of 2, log base 9 of x cubed, and log base 9 of 3. Every single logarithm needs a base. That's a common mistake to forget it. Now these two terms were multiplied, so I should be adding their logarithms. This 3 was divided, so it should be subtracted. And only other thing is if you can simplify, then do it. Like this can't be simplified. You need a calculator, so just leave it. First of all, that 3 needs to come down there. And I can do log base 9 of 3 in my head pretty easy. It's a half. Okay, one more example, and then we'll move on to some condensing action. This one, log of x y squared over the square root of z times w. This is all one big parentheses. So here are the first two steps of the process. Now you might be wondering why I did it a little differently here. I'm going to do it the long way out. I'm going to show every single step to prove why a shortcut works. So right here, I have a numerator and I have a denominator. So what I did is I said, okay, all of this yellow stuff, I will expand it in a minute, but because the yellow and the green are divided, I'm going to subtract the yellow and the green so far. Now I'm obviously not done yet because I have two more things multiplied. So they each get their own logarithm and they're added because these things are multiplied. Now right here, what really is happening is z and w are multiplied. So their logarithms should be added. And I'm putting big square brackets around here because it was minus the whole green thing. And this is still the whole green thing. But to really simplify all the way, you have to get rid of those brackets. And the only way to get rid of them is to distribute that negative here and here. I'm going to bring the 2 out front. So I have minus log. Now I can't have a radical anymore, so let's put that there. So now I have minus log of w. The only reason I wrote that all out is because some people don't like how I'm subtracting both of them, because they're like, look, w is multiplied, it should be added. Well, it was, but because I distribute the negative, it's subtracted. So here's the key. Anything in denominator, any term that's in the denominator gets subtracted in the end. So you might as well just jump right to subtracting. Save yourself a step. And I really can't leave that 1/2 up there. I'm going to bring the 1/2 down front where it should be. All right, cool. Let's move to some problems for you to try. Pause the video right now. You're going to write these 4 down. I want you to try them, expand them all out using those properties. And in just a second, I'll show you the answers. Obviously, do not move to the answers until you try these 4. You're not really going to learn the best if you're just copying my work without trying it. Here are the answers with all the steps shown out. If there's any you're not sure on, put a star next to it or something so that in class you can ask me and I can address any issues. Now let's move on to condensing, the exact opposite. So before I had one logarithm and I spread it out to multiple logarithms, added or subtracted, something like that. Now what's going to happen is I'm going to have many logarithms that are added or subtracted, and I'm going to go to a single logarithm. Now when you do that, so when you condense, what's going to happen is it's the exact opposite again. All radicals should return. So there should be no more fractional exponents. And one thing to keep in mind is when we condense, we're always going to go left to write. So for example 1, let's do a relatively easy one again. And we'll build our way up as always. I have 3 different logarithms. All of their terms are added. So the logarithms are added here. So what's going to happen is to go backwards, you're going to multiply. That's that property number 1. Example number 2. So again, I only write a single logarithm. You shouldn't be writing ln more than once. If you do write it more than once, it means you made a mistake or you need to simplify more. And again, you can only condense if all the logarithms have the same base. So here the base was e, here the base is 3. Now there are 2 different ways to approach this. One way is to say, oh, log base 3 of 9, I know that. That's just 2 minus log base 3 of x. So now I have 4 minus log base 3 of x. And there's nothing to condense. You can't condense a number in a logarithm. Where the condensing could come into play is if I brought the 2 up top. So I did the reverse of property 3 that we were doing before. And then I have log base 3 of 81 minus log base 3 of x. And then if I have 2 things that are subtracted, I can write them with a single logarithm since the base is the same and they're divided. So those 2 are a little bit easier. Let's move to 2 that have a little bit more work involved. So let's try log of 3. So I'm doing the common logarithm. They all have a base 10. All right. So I have, this is a minus sign, by the way. I have 2 terms that are added and 1 term that's subtracted. So what you could do before you did anything else is bring this 1/2 up top to be an exponent. And then you could realize that, well, these 2 are added. So that means that when I go to a single logarithm, they should be multiplied. And instead of doing square x to the 1/2, let's jump right to square root of x. Now this term is subtracted, and we talked before how anything that is subtracted needs to go in the denominator. So that's going to go down there. And now what you could do is combine these x's and simplify even more. So we'll practice that type of simplifying more tomorrow. Okay, last example I'll do out with you here is what if I have 3 times the natural log of x plus 1 plus 2 times the natural log of y minus natural log of w minus natural log of 2. All right, first of all, let's bring the 3 up top. Oh, here's another one that needs to go up top. And all right, I have 2 logarithms that are added. So that means multiplying. And then I have a logarithm subtracted and a logarithm subtracted. Now we need to remember how I said before, anything in the denominator is subtracted. Well, the reverse is also true if you say it. Anything subtracted is going to go in the denominator. So w plus 1 cubed and y squared will be multiplied because I'm adding. And then w is going to go in the denominator as well as 2. They're going to be multiplied in the denominator. There we go. That's pretty much fully simplified. All right, so I have some for you to try here. Let's see how you do. There are 4 different examples. I'd like you to condense them into a single logarithm. So pause the page now, write these down, try them out. And on the next page, I'm about to put up the answers. Actually, didn't I just do this one with you? Oh, I did one really similar. It's not the exact same, but these 3 are a little bit different. And here are the answers with the work, and the fully condensed answers are at the end. So here's the bookwork I want you to try. In class, I'm going to do a quick check to see how you did on the bookwork and the notes. We'll do whiteboard practice of more complex expanding and condensing because they get more difficult, but I want to save that for in class. And then we'll use that for solving more difficult equations. All right, I will see you tomorrow. Have a wonderful day.